Hello friends, welcome to my channel. What if I ask you that you can see the distance measured by this ultrasonic sensor using these glowing LEDs, right? So in this video we are going to map the distance measured by the sensor using these number of LEDs like this. If I move the object closer to the ultrasonic sensor, the LEDs will keep on off. And if I move the object away from the sensor, the LEDs will start glowing. Right? So let's start building this project. So the components that we are required for this project are Arduino Uno, a breadboard, a set of jumper wires, ultrasonic sensor and few LEDs. Now we will start building the circuit. So first of all let us place the LEDs. So connect the negative terminal of the LED on the negative rail of the breadboard and positive end to the other side. So all the LEDs have been connected. Now let us start connecting the ultrasonic sensor. Now we will start connecting the ultrasonic sensor. So for that we have 4 jumper wires here. Red will be used for VCC, brown will be used for ground, and other 2 will be used for trig and echo. So first of all let us connect these jumper wires on the breadboard. Right, and you can see the pin out of the ultrasonic sensor. The ground is on the extreme right and VCC is on the extreme left. So place the ultrasonic sensor like this, right, and this pin will be going into your Arduino. So now let us connect the jumper wires of the LEDs. So keep on placing the jumper wires for each of the LEDs on the breadboard. So first of all let us start from the green one, right. So the LEDs has been connected with the jumper wires and these pins will be going into the Arduino Uno. So we have total of 9 LEDs here and we will connect these jumper wires of the LEDs on the Arduino pins starting from pin number 2, 3 and all the way up to 11. And please note that we are skipping pin number 9 because it has been damaged. So let us start placing the jumper wires on the Arduino pins. So all the pins of the LEDs have been connected. Now we are left with the trig and echo pins of the ultrasonic sensor. So yellow pin is a trig pin and orange pin is a echo pin. So let us place these pins on the pin number 12 and pin number 13. Now we are left with the power supply of the ultrasonic sensor and the LEDs. Now we will connect the ground and the VCC of the ultrasonic sensor. So let us place first the ground, that means the brown wire, to the left of the pin number 13, which is the ground pin of the Arduino. Now this will be going into the 5 volt of the Arduino. So you can see the 5 volt is the 4th pin from the right, like this. Now we will take another jumper wire and we will connect the LED's negative terminal to the ground of the Arduino. So now all the circuit have been completed. Now we are left with the code. So this is the code for our project. Here we are defining 2 pins for ultrasonic sensor and total of 9 LEDs starting from pin number 2 and all the way up to pin number 11. And we are defining all the LEDs as the output pins. And in this function get distance, we are calculating the distance calculated by the ultrasonic sensor. And pulsion is the function which calculates the time taken to send the ultrasonic waves plus time taken to receive the ultrasonic waves. Now here comes the main logic of our program, which is this loop function. So in this function we are defining the LED count variable which stores the number of LEDs which are on at a particular time. And if the object is within this distance 5 to 20 centimeter, we are mapping the distance variable from this range to this range 0 to 9. And suppose if the object is at 5 centimeter, so this 5 will be mapped to 0, and if the object is at 20 centimeter, it will be mapped to 9. That means the maximum value of LED count is 9 and the minimum value of LED count is 0. And if the object is at greater than 20 centimeter, the LED count should be retained to 9, Otherwise, the LED count should be retained to 0. That means the LED count should be varying between 0 to 9. And this is the loop function, which is looping on each LED. So it loops through all the 9 LEDs one by one. And for each index I of the LEDs, if the I is less than LED count, it turns on that LED. Otherwise, if I is greater than the LED count, it turns off that LED. Suppose if LED count is 4, that means the LEDs at index 0, 1, 2, 3 will be on, and the LEDs at index 4, 5, 6, 7, 8 will be off, right? So I hope this program will be clear to you. If you have any doubt regarding this project, you can comment down below, and I will answer that question. We will meet in another video. Till then, goodbye.